In this video, we will solve this recycle degree of freedom problem. And so if you want, you can pause the video here and attempt to solve the problem. We will solve N1, N2, N3, N4, N5. So let's get started. So for this problem, the first thing we're going to do is do a degree of freedom. For example, I'm going to do this one kind of mentally. If I said my system is this, I would have three unknowns, N2, N4, and N3, and only two balances, A and W. So that's not going to work. But what if I said my system boundary is the overall system, meaning this? My system would therefore be this. So we would ignore everything inside, and we would only consider this, this, and this. And by doing this, we would get a degree of freedom of 0. So we would have a degree of freedom for the overall system. We have how many unknowns? So for the overall system, we're ignoring this terms right here and just focusing on the overall system. So N1, N3, and this 200. So we have two unknowns, N1 and N3. So two unknowns, N1, comma, N3. And how many equations can we write? How many balances? We can write two equations, A and W. Or you could also say A or W, or A in total, or W in total. Because together, this is total. So let's get started. First thing we can do is a simple total. So a total balance. So total. If we do that, we can say that we don't know N1, and that's going to equal, so N1 is our input. Input is equal to output. Output is N3 and 200. So N3 plus 200. So we have two unknowns, so we can't solve anything yet. So we need another equation. The next equation could be a balance. If we did W could also work, but if we do A, just this and this. So we can call it an A balance. So we can say N1 times 0.8 is equal to 200 times 0.95. And by doing this, we would get N1 is equal to 237.5 moles. So that's one answer we can box in. And next, if we plug in 237.5, then our N3 would be 37.5 moles. So now we have two answers. We have 3 more to go. So next, we can do a balance on this. And we can check how many unknowns do we have. We now know N1, we don't know N5, and we don't know N2. And we have two balances, A and W. So that could also work. So we'll do that next. So we have 237.5. So we will do a total balance. A total balance from this perspective, from this system's perspective. So that would be 237.5 going in, plus N5 is also going in. This is going into this system right here. So N5, and that's going to equal N2, our output, N2. Now N2, we don't actually know, so that's two unknowns. So we need another equation. Next we could do an A balance. So A balance, so that would be 237.5 times 0.8, this right here, plus N5 times 0.95, and this is going to equal our output. Output is going to be N2 times 0.9. N2 times 0.9. So we have two unknowns, N2, N5, and N2, N5. So now we will have to use a calculator. So I'm going to pull up my TI Inspire. So I will hit menu, 3 for algebra, 7 solve system of the equation. We have two unknowns, so n2 comma n5, two unknowns, and we simply write down the two equations, two unknowns. 237.5 plus n5 is equal to n2. First equation. Next, 237.5 times 0.8 plus n5 times 0.95 is equal to n2 times 0.9. We hit enter. So we get n2 is 712.5 and n5 is 475. So I guess we can write it down right here that n2 is equal to 712.5 moles and n5 is equal to 475 moles. So now we have 4 out of the 5 answers. So the fifth one is going to be super easy. So we know this. We just need to know n4. So we have n2 is going in, and two things are coming out, this and this. So I could even fit it right here. It's going to be super simple. So I'll fit it in right here. So n2 was 712.5. This is going in, and what's going out is n3 and n4. n3 is this number right here, 37.5 plus n4. So now we can solve. So n4 is going to equal 675 moles. So we can box in this. And now we can do a quick check. Now this is not an official check, just a really fast check. 237.5 plus n5, 475. 237.5 plus 475 is going to equal 712.5. You can check with a calculator. So n1 plus n5 is equal to that, which is correct. Next, we could say that, let me think, n5 times 0.95 plus n1 times 0.8, is it equal to n2 times 0.9? If it is, we're just further checking. So that's a good strategy at the end. If you have any extra time, just keep on trying different scenarios to double check that what you have now is correct. And that's all you need to do for this problem.